So now let's talk about pool table physics. Oh, it says it's oh, this is better. I think this works. Yeah, it's recording, but you can see it a little bit better. All right. Let's say now that we have, when I say pool table physics, I'm talking about objects that hit each other, strike each other, maybe not perfectly in alignment. If they're off-center just a little bit, then when they rebound, they will go off at an angle. So let's start with a Twinkie that flies through the air. Twinkie has a fairly small mass because it's puffed full of air, 0.25 kilograms. And the Twinkie hits a can of Coke because there's not enough sugar in the Twinkie. And the Twinkie's going, it's flying upward, clearly. And the Coke has a mass of a half a kilogram. And they're going at the speeds that I'm going to give them at the moment that they hit each other, okay? So it was chucked upwards.
There's going to be a magnet.
Yes, because Coke cans are iron. Mm-hmm. That's okay. Yeah, there's like an air tunnel.
Is there like a magnetic constant where, like, depending on the size or the strength of the magnet, it's like the same number that it like accelerates something at?
Sure. I mean, I think you're thinking about like weight. So in other words, could you levitate something if the magnet was strong enough? The answer is yes. We call them maglev trains. Yeah. And they go really fast. Yeah. All right. Let's say that this velocity is 16 meters per second. And the Coke can, when it strikes the Twinkie, is moving at 6 meters per second. Now, because the Twinkie is filled with cream filling, we get an inelastic collision. Okay? So then the Coke can Twinkie combination will do what? Point in the direction that they will travel off together. Yeah, come on. Point with your physics pointy finger. Well done. Good. Like that. All right? So the can Twinkie combination will move rightward and upward. Now the good news is, and we want to know how fast and at what angle. So the good news here is that when we were doing problems with equilibrium, remember how we said lefts equals rights and ups equals downs? That is also true for momentum in 2 dimensions. So we're going to transfer the horizontal momentum before the collision to the horizontal momentum after the collision. So what was the horizontal momentum? Momentum. 4. Right, 16 times 0.25. See how I made up nice numbers for you? So that's 4, right? 4 kilogram meters per second. I'm going to put that right here because that's the horizontal momentum. 4 kilogram meters per second. Notice that's not velocity, it's not mass, it's both, it's momentum. What's the vertical momentum?
3.
Yes, 3. Correct. Oh, somewhere in between. There we go. 3 kilogram meter per second. Thank you, dear. Just put it right there. Those are our test packets. Okay, so 3 kilogram meters per second vertically. Now, if you didn't know anything else, and I told you you had a right triangle over here that had one side that was 3, one side that was 4, what would the resultant hypotenuse side be? 5 is correct. So the momentum is 5 kilogram meters per second because momentum is conserved. But that's not the velocity. How do you find the velocity?
The total mass.
Divide by the total mass, correct. So momentum is mass times velocity, so this is instantaneous momentum. The mass would be 3/4 of a kilogram, and the momentum is 5 kilogram meter per second. It's all for V. Yeah, 6 2/3. Okay, so that's simple. Easy peasy, right? Okay. Of course, it'll get a little harder. Just when you understood. Angle, you can use any of your trig functions, but make sure you use the 3, the 4, and the 5, not the 3, the 4, and the 0.67. Your sides of the triangle need to be apples and apples, so they need to be the same units. So the tangent would be equal to the opposite side divided by the adjacent. Notice those are both momentum numbers. Okay? So far, so good? All right, let's... Is gravity slower?
If you drop something,
Oh, would objects? Sure. Actually, theoretically, that's correct. It is. Sure. It would be like, you know, if you had a very dense atmosphere like on some of the gas giants, yeah, then certainly that would have an impact on how fast things would fall. Okay. Let's try another one and see if you can get this on your own.
They've been trying to do that for years. If you just don't worry about the other countries and disaster involved. I don't know. Maybe they're really bad.
I heard that they're thinking, the Communist Party in China is thinking about repealing or giving special exemption to families that, to have more than one child.
Yeah, I heard, I just heard that,
But I don't know why. What would you have to do to qualify for 2 kids?
China to relax decades-long one-child policy, and they will also abolish labor camps.
Yeah, that's big.
My paternal grandparents are farmers and live up in the mountains. They're allowed to have 2 children.
Oh, really?
Yeah.
Just because in farming communities the population's not really a problem, or?
Well, I think it's like
If you have a girl first, too.
No,
But if you have a girl first, you can have another child.
none of those things.
Okay, how many grandparents do you have living in China?
I've had people like that they
Okay.
Usually girls are put up for adoption.
Yeah, I know that they've kind of lost a generation in terms of the equity, right? In terms of number of girls versus men versus women. So there's, yeah, it's like.
So they're trying to, like, they don't want to have the women adopt right now, so they change.
All right, this is an inelastic collision. So now we get a 5 kilogram mass. Figure out the velocity and the angle. Go. Spirit, did you get this one? What did you get for a velocity? That's correct. How about an angle?
What's 53 degrees?
53 degrees is correct. The horizontal momentum is 3 times 1. The vertical momentum is 4. So how can I have a 3, 4, 1 right triangle? Right, the momentum this way is 5, so P equals 5. And then use any of the trig functions you'd like to solve for the angle. All right, one more, and then we're going to do our little ACT prep thing. Okay, so now let's make this a little bit harder. Let's say before collision, we have a 3 kilogram mass moving horizontally at 2 meters per second. And a 2 kilogram mass moving upward and leftward, okay? And they're going to strike somewhere here. 4 meters per second at 20 degrees above the horizontal. Good question. So then they collide. The 3 kilogram mass gets pushed upward and backward, okay? So the 3 ends up this way. We're going to call that V1, and the angle is 15 degrees. The 2 kilogram mass will end up being pushed rightward and downward. Its velocity is V2, and the angle here is 5 degrees below the horizontal. So I'm going to do this one as a sample for you. And this is going to be online as well. So if you just want to watch, you could certainly pull this up and take a look at the notes over the weekend. So horizontally, we have 3 times 2, right? And we're going to make to the right positive and to the left negative. So we'll get to that in a second. So 3 times 2 minus the horizontal momentum from this one. Because, since we said right was positive, left will be negative. Now the horizontal velocity, so this is just going to be a velocity vector, is 4 cosine 20. That's the horizontal velocity. We'll put the vertical in a minute. Just the velocity is 4 cosine 20. So 4 cosine 20 is the velocity. To make that momentum, we have to multiply by the mass. Okay? We're going to do the same thing with the 2 horizontals after the collision. This horizontal component is going to be V1 cosine 15, and that'll be negative. It's backwards. I'll put negatives by these guys. This one will be V2 cosine 5 degrees, and that's going to be positive because it's to the right. So again, it's the momentum that's conserved, so watch what we do here. Negative V1 cosine 15 is the velocity, and we need to multiply that by the mass. Positive V2 cosine 5 is the velocity, and we'll multiply that by the mass. So now you have this big, long expression which represents all of the horizontal momentum. Vertically, I'm going to make up positives, so this vector will be 4 times the sine of 20. So same thing over here. This one's going to be V1 sine 15. Those are positive because they're up. And then this guy is going to be negative. So negative V2 sine 5 degrees. So the vertical momentum will be 0 for this guy, plus 4 times the sine of 20, that's the velocity, and then to remember it's momentum that's conserved, not velocity, so I have to include the mass. After collision, I'll have positive V1 sine 15 degrees times 3, minus, because this is going down, V2 sine 5 times 2. So now that big old hot mess can be solved through substitution. You have V1 here and here. You have V2 here and here. So solve for 1 and substitute. The answers to these, so I will just write substitute and solve. And then you could do this over the weekend. Are V1 equals 4.9 meters per second, and V2 equals 6.3.